Down here, says x to the third to the fourth power. So notice this is a little bit different than what we did at the top, where it was x to the third times x to the fourth. This one is x to the third to the fourth. Well, x to the third to the fourth would mean that you have x to the third times itself 4 times. And each one of those x to the thirds is x times itself 3 times. So as I count my x's, I see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There are 12 x's there, so that would be x to the 12th. Y to the second to the fifth means you would have y to the second times itself 5 times. And each one of those y to the seconds is y times itself. And once I get all those y's written down, how many y's do you see? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that would be y to the 10th power. So can we come up with a generalized rule for this instead of writing out all those x's and y's? And we can. We have what's called product of powers. To find the power of power, multiply the exponents. So b to the third to the fifth would be b to the 3 times 5, which is b to the 15th. G to the 6th to the 7th, you would take 6 times 7, which would be 42, or g to the 42. So again, notice that you have 2 exponents sharing the same base. So if we go up here to the top, we had x to the third times x to the fourth, and that equaled x to the 7th, because this is what that problem looked like. The x to the third times x to the fourth. That equals x to the 7th. Notice that each variable has its own exponent. They have their own bases. They have their own individual x's. Whereas over here, one x was sharing 2 variables. So the 3 and the 4 variables both share the x. So that's the difference between the two. We're going to multiply on the left one, and on the one that's in the middle, we're going to add the exponents. So 13 is 4a to the 4th, b to the 9th, c. So again, 4, that is a whole number. So we're not going to take 4 times the 2. We're going to take 4 to the second power. 4 to the second power is 16. 4 was not an exponent. So 4 to the second power is 16. And then we're going to take every one of those variables with exponents times the 2. So a to the 4th to the 2nd would be a to the 8th. B to the 9th to the 2nd, 9 times 2 is 18, so that's b to the 18th. And then the last one would be c, and there is a first power there, remember, so it's c to the 1st to the 2nd, and 1 times 2 is 2. So the answer would be 16, a to the 8th, b to the 18th, c to the 2nd. 14. Again, negative 2 is an integer, it's not an exponent, so we are going to take negative 2 to the 3rd power. So what is negative 2 to the 3rd power? Well, that means negative 2 times negative 2 times negative 2. When you multiply the first 2 negative 2's together, you get a positive 4. But then when you take it times the last negative 2, positive 4 times negative 2 is negative 8. So that would be negative 8 when we take negative 2 to the 3rd power. And then f to the 2nd to the 3rd power. So this time we have an exponent of 2 there. So we are going to multiply the 2 and the 3 together because the 2 and the 3 are both sharing the f. So that would be f to the 6th. And then I got g to the 3rd, so 3 times 3 is 9, so g to the 9th. And then finally, h to the 2nd to the 3rd would be h to the 6th. And then finally on 15, I have negative 3, p to the 5th, t to the 6th. So again, if we take negative 3 to the 4th power, that's negative 3 times itself 4 times. So negative 3 times negative 3 times negative 3 times negative 3. Well, Let me write it over there, but I'll put it over on here because it says I'm running out of room. Okay, so the first two negative 3's, negative 3 times negative 3 is positive 9. And when we multiply the last two negative 3's, we also get positive 9, and 9 times 9 is positive 81. So negative 3 to the 4th power is positive 81. And then p to the 5th to the 4th would be p to the 5 times 4 is 20. And then t to the 6th to the 4th power would be t to the 24th. So there's your final answer on that one. Then finally we can combine everything. It says simplify each expression. So 5x squared y and then that's to the 2nd power, 2xy to the 3rd z, and that's to the 3rd power, then 4xyz without a power outside. So I can't do anything inside of parentheses, so the next part of order of operations would be to do your exponents. We are going to take everything in this set of parentheses to the 2nd power using the rules we just have on the last two sections. So again, 5 to the 2nd power, that's 25. It's not an exponent, so take 5 to the 2nd power. X to the 2nd power is x to the 4th because 2 times 2 is 4. And then y, there's the hidden one, y to the 1st to the 2nd would be y to the 2nd. We'll take that times what's inside of this parentheses to the 3rd power. 2 to the 3rd power is 8. X to the 1st to the 3rd power is x to the 3rd. Y to the 3rd power is y to the 9th. And z to the 1st to the 3rd power is z to the 3rd. Times nothing in the last set of parentheses to a power, so just 4xyz. I'm just going to write that down there. Now we're going to multiply all three monomial terms that we have left. So starting with the whole numbers, 25, 8, and 4. When you take 25 times 8 times 4, 25 times 8 is 200. 200 times 4 is 800. When we multiply x to the 4th, x to the 3rd, and x, they all have their own exponents. So we are not multiplying on this part. We are adding the exponents because they all have their own bases. So x to the 4th, x to the 3rd, and x to the 1st would be x to the 8th because 4 plus 3 plus 1 is 8. And then y to the 2nd, and then y to the 9th, and then y to the 1st. So y to the 2nd, y to the 9th, y to the 1st, that would be 2 plus 9 plus 1 would be y to the 12th. And then finally, the z's, there isn't any z's in the first monomial, but we have z to the 3rd times z to the 1st, that would be z to the 4th. And then that one is simplified because we don't have any doubled up variables and we don't have any numbers that can be multiplied together anymore. So the last one is similar to that. The first set of parentheses does not have any exponent on the outside of it. I'm just going to bring it down. But the second one does. So I have negative 3 to the 2nd power, which is positive 9, because negative 3 times negative 3 is positive 9. G to the 1st to the 2nd is g to the 2nd. And then j to the 4th to the 2nd is j to the 8th. Again, since the j has two exponents affecting it, it's got the 4 and the 2 that's on the outside, we multiply those exponents. And then the last one. Now it says negative GHJ. Since there's a negative sign out in front of it, that's like saying there's a negative 1 there. And when you take negative 1 times negative 1, you get positive 1. And I don't need to write a 1 in front of a variable, so there's not going to be any negative or any 1 in front of that variable, because negative 1 times 1 is positive 1, but I don't need to write 1s in front of variables. And then you have g to the 1st to the 2nd, which is g to the 2nd. H to the 1st to the 2nd is h to the 2nd. And j to the 1st to the 2nd is j to the 2nd. And now I'm going to multiply all the numbers together, all the integers together, and then add the exponents because I don't have, each of the exponents is going to have its own base. So negative 2 times 9 is negative 18. And then I've got g to the 3rd, g to the 2nd, and g to the 2nd. 3 plus 2 plus 2 is 7, so the g to the 7th. And then I just have h to the first power. No h's in this middle term, and then h to the second power, so that's h to the third power when I add 1 and 2 together. And then for my j's, the first monomial has no j's in it. J to the 8th, j to the 2nd is j to the 10th.